Hello everyone. Today we have Pre-Calc lesson 24, sums of trig functions and combining functions. Okay, for sums of trig functions, okay, every single time we do this, we are going to use exact answers from our reference triangles. So, for example, what an exact answer is, right, if we have this reference triangle and I asked for the cosine of 30, the cosine of 30 is root 3 over 2. That is an exact answer. Okay, not some crazy decimal. I think it gives you 1 point something something, or it's like 0.8 something something something. Not that. Okay, we want exact answers. This is an exact. So let me show you with an example. Okay, we're going to evaluate the cosine of 60 plus the sine of 45. Okay, now this requires both of our special triangles, so I'm going to draw them both here for our reference. We have our 45, 45, 90, which is 1, 1, root 2. Our 30, 60, 90, which is root 3, 1, 2. Okay, the cosine of 60, if I go to my 30, 60, 90 triangle, cosine of 60 is adjacent over hypotenuse, so this is 1/2. And the sine of 45 is the same as the cosine of 45 because it's an isosceles triangle, so we can use either one. Sine of 45 is 1 over root 2. Now we cannot leave our answer like this for two reasons. One, we need to combine it into one fraction, and the other reason is we cannot have a radical in the denominator. Okay, so I am first going to combine these into one fraction. I'm going to multiply this equation by 2 over 2. I'm going to multiply this equation by root 2 over root 2, leaving me on top with root 2 plus 2 over on bottom 2 root 2. Now I need to rationalize the denominator, so I multiply the top and the bottom by root 2 over root 2. Distribute your root 2 here, so this gives me 2 plus 2 root 2. On bottom I have 2 times 2. So I have 2 plus 2 root 2 over 4. I can cancel out a 2 from each of these, leaving me with 1 plus root 2 over 2, and that is my fully simplified answer. Okay, I have no radicals in my denominator, and I only have one fraction. Okay, let's do another example. We'll do lots of examples, actually. We're going to evaluate the tangent of 30 plus the cosine of 45. Okay, so I go up to my triangle here. The tangent of 30, I know tangent is opposite over adjacent. So tangent of 30 gives me 1 over root 3. And cosine of 45 is the same as sine of 45, which we already found was 1 over root 2. Okay, now again, I need to combine these into one fraction. I'm going to multiply this one by root 2 over root 2, this one by root 3 over root 3. This gives me root 2 plus root 3 over root 6. And I rationalize my denominator, multiplying the top and bottom by root 6 over root 6. Again, I distribute. Okay, so this gives me on top root 12 plus root 18 all over root 6. And I know I can simplify root 12 to 2 root 3 and root 18 to 3 root 2. Sorry, this should be just 6 on the bottom. Root 6 times root 6 is just 6. Leaving me with 2 root 3 plus 3 root 2 all over 6. Okay, let's do another example. We want to evaluate the tangent of 45 plus 2 tangent of 30. Okay, I'm going to redraw my reference triangles as it's a new page. 30, 60, I have root 3, 1, and 2. And my 45, 45, 90, I have 1, 1, root 2. Okay, so the tangent of 45, I have 45 here, doesn't matter, either one. Okay, tangent is opposite over adjacent. Tangent of 45 is nice because it's just 1. The tangent of 30, I have 30 here, I have opposite over adjacent, so I have 2 times 1 over root 3. The 2 just kind of goes along for the ride. Okay, now this simplifies to 1 plus 2 over root 3. Again, I want to combine into one fraction, so I'm going to multiply 1 by root 3 over root 3, leaving me with root 3 plus 2 all over root 3. And I'm going to rationalize my denominator. Never, ever, ever leave a radical in the denominator. I hope I said it enough that no one does that ever. Root 3 times root 3 is 3. Then I have 2 times root 3 all over 3. And I'm done. I cannot cancel these two 3's. Okay, because there's 2 actions happening in the numerator, I cannot cancel them. All right, let's do one more example like this. Okay, we want to evaluate root 6 times the sine of 30 plus 1 over root 2 tangent of 60. Okay, so we go up to our 30, 60, 90 triangle. The root 6 is going to go along for the ride. And the sine of 30 is opposite over hypotenuse, which is 1/2. Over here, 1 over root 2 is going to go along for the ride. And tangent of 60 is opposite over adjacent, which gives me root 3, or root 3 over 1. Okay, simplifying this gives me root 3 over 2, root 6 over 2 plus root 3 over root 2. I want them to have the same denominator, so I'm going to multiply this fraction by root 2 over root 2, this fraction by 2 over 2, leaving me with root 18 plus 2 root 3 all over 2 root 2. I'm going to first simplify root 18. I know it simplifies into 3 root 2 plus 2 root 3 over 2 root 2. If you're unsure how to simplify radicals, please make sure you come and see me in student hours to make sure we can figure that out. And again, like we've done in every other problem, I'm going to multiply the top and bottom and rationalize it to get rid of my radical. Distribute. So this gives me 3 times root 2 is 2 plus 2 root 6 all over 2 times 2. Now, I have a 2 in each of these. I can just go ahead and cancel it before I multiply. And this leaves me with 3 plus root 6 all over 2. You can leave it, as I've done in all of them, as just one fraction. You don't have to break it up into 2 fractions because we don't have imaginary numbers. You only do that if we have imaginary numbers. All right, let's move on to combining functions. Okay, so combining functions, we can combine them in a couple different ways. The sum, so we have 2 functions, f of x plus g of x. We write this as f plus g of x. Okay, you will most likely see this form, f plus g of x, and we know we can break it up into adding these 2 functions. I'll show you what that looks like in a minute. Okay, we can have the difference, f of x minus g of x is f minus g of x. Notice how I'm saying it. It's not f times x, it's f of x minus g of x equals f minus g of x. Okay, then we have product, f of x times g of x. We write as f g of x. The quotient, f of x over g of x, we write as f over g of x. And composite functions, we have f evaluated at g of x, which we write as f of g of x, or fog, okay? This is also saying f of g of x, right? These two notations are the same, but we often just refer to it as fog. Now, all of these can be in the reverse order, right? We can have g of f of x, which would be goth of x. Doesn't matter which one comes first, right? This could be g of x plus f of x. We'd have g plus f of x, okay? As long as you're keeping the order consistent. So let's do examples of what this actually looks like, not those. So example 6, we're going to say f of x equals the log of x, and g of x equals x squared plus 6. We want to find g of f of x. Okay, so g of f of x, what's that saying is g of f of x, which means in my function g of x, wherever I see an x, I'm going to plug in f of x. So g of f of x, g of x is x squared plus 6, but instead of writing x squared, I'm going to write the log of x. So I'll have the log of x squared plus 6. That's my answer. I'm not solving for anything. I'm not plugging in any numbers. I'm putting one function into another. Let's do another example. Let's let f of x equals x plus 2 and g of x equals x squared plus 3. Let's first find f plus g of 6. Now, f plus g of 6, that's the same thing as saying f of 6 plus g of 6. This time we are actually plugging in a number. So this is my function f of x. F of 6, I plug in a 6 for x, so I will get 6 plus 2, that's f of 6, plus g of 6, I plug in a 6 for x here, 6 squared plus 3. Right, so in this case, 6 plus 2 gives me 8. 6 squared is 36 plus 3 is 39. So altogether, this gives me 47. Okay, in this case, I'm not just plugging in a variable, I'm plugging in a number, but I'm plugging it in for x here and for x here. Same thing if I have f minus g of 6. That's the same thing as saying f of 6 minus g of 6. So f of 6, I know I have 6 plus 2. Now I'm going to put the whole thing in parentheses, okay? Because I'm subtracting all of g of 6, which is 6 squared plus 3. I'm subtracting the whole entire thing. Now we already talked about this was 8, and this was 39. Giving me 8 minus 39, I'll have minus 31. Now, if you'll notice, f of 6 stays the same. F of 6 is always 8. G of 6 is always 39. Once you find it for the first function, we're just using it in different orders. So for our next one, that was 1, 2, 3, f times g of 6, that's the same thing as saying f of 6 times g of 6. Well, we know what f of 6 is. F of 6 is 8, and g of 6 is 39. So we have 8 times 39, which is 312. And likewise, when we have f over g of 6, that's the same thing as f of 6 divided by g of 6. F of 6 is 8, and g of 6 is 39, and we can't simplify that, so it stays the same. Okay? We can do this with anything. It doesn't have to be a 6. It could be an X, it could be a Y, it could be a Mrs. Smith, it could be you, it could be any number, right? As long as we just continue to use the same function and plugging it in for our variable. You'll have plenty of practice with this on your homework tomorrow, but that is all for tonight.